Hey, this is Mr. Ariel with the Names and Formulas practice. Today we're going to learn how to write the names of chemical formulas and how to write chemical formulas from chemical names. Right now, you should have a sheet that looks like this. Work along with the problems on the paper as I complete them in the video. Later on, you'll have a chance to practice without my help. Today, it's just about getting the basics down. Now, you should also have a sheet with a whole bunch of rules on it. It looks kind of like this. Make sure to take it out of your notebook so you can refer to it while we work. You'll eventually get all of these rules memorized simply by practicing the skills, but for today, it helps to be able to use it as we go along. Now first up, you should see a line that divides your page into two parts. It might feel strange to start in the middle of the page, but there's a reason for it. Every time you see one of these problems, the first thing you have to do is determine if you use the rules for ionic substances or for covalent substances. Now, if you go check your rule sheet that I asked you to take out, you should see this part in the top right corner of the page, where it says the first step to any problem, is it ionic or covalent? Now, to answer that question of whether we're dealing with ionic or covalent rules, we have to figure out if we have a metal and a nonmetal or two nonmetals. So, checking this formula right here, calcium is on the periodic table on the very left-hand side, and so that means it's a metal. And chlorine, on the other hand, is way towards the right-hand side with all the nonmetals. You could check the other three substances above this one on the sheet, but all of them are going to fall into that pattern of a metal and a nonmetal. That means they're held together with ionic bonds, and so we'll record that these are all ionic because they're metal and nonmetal. So let's jump up to the first problem on the page, and that's NaCl. Now, because we've already said that it's ionic, we can pull up this set of rules from that other sheet. Now, NaCl is a formula, and so I'm looking at the rules for naming that formula, because we need to turn NaCl into an actual chemical name. Now, it looks like the first step is to write the name of the first ion, and Na on the periodic table is sodium. And so I can write that part of the name. Now the second step right here is we need to write the name of the second ion, but we change the ending to IDE. And Cl on the periodic table, that's chlorine, but again I've got to change the ending to IDE. Now the next three problems on the page are definitely going to follow the same set of rules. If you feel like you've got the hang of it, go ahead and try the next three and then come back when you're done and check your answers with mine. Now for this one, we've got NaF. And so we already know from the periodic table that Na stands for sodium, and F, if we look on the periodic table, that would be fluorine. And so I'm going to write the first part of the name for fluorine, but I have to change the ending from INE to IDE. And so this problem is done. Let's go ahead and move on to the next one. For this one, we've got Li and S. And so I can write the first name from the periodic table that Li is lithium. S on the periodic table is sulfur, but this one I have to drop off the ending again, and so that would be SULF, but I'm going to drop the ending and replace it with IDE. And so we've got lithium sulfide. Now it's really important to note right here that there's a 2 in the formula, but I do not have to record that information in the name. You're going to see where we will later, but for ionic substances, we never have to look at the subscripts in a formula to help us with a name. So let's do the last one in this section, and that's CaCl2. And looking on the periodic table, Ca, that's calcium. And then Cl, we already know from this practice, is chlorine. And so I'll write it and change the ending of the second one to IDE. And we have calcium chloride. And so that's it for the first four problems on this part of the page. Moving on a little bit, we're back to that middle line that we filled out the top part before. Now under the line, we're going to switch the set of rules we're going to use. Looking at CF4 right here, carbon is a nonmetal and fluorine is a nonmetal too. And so that means this is a covalent substance because we have two nonmetals. Now I'll do one of these, and then you can work ahead of me if you like. For CF4, we're going to pull up the set of rules for naming covalent substances. And the first rule right here says look at the subscript on the first element and find the prefix that goes with that number. Now, looking at carbon, there's no subscript written to the right of it. And technically, that means that there's one atom of carbon, but we never ever write a subscript of 1. We just leave it out for simplicity. Now, if we found the prefix that goes with that number, if we had one atom of an element, the prefix we would use to indicate 1 is mono. And so we've completed step 1, and now we're looking at step 2, where we write the prefix and the name of the first element. And so that would be monocarbon for the first part of the name. Now, it's really important to notice this little asterisk down at the bottom. It's sort of the exception to the rule. The mono prefix can be skipped on the first element. And so we're actually not going to write mono on carbon. And so I'm going to bring that over here. Now for step 3 says repeat the process for the second element. And so if we look at the 4 on fluorine, that means if we have 4 atoms, we're going to use the prefix tetra. And so now I can write the prefix tetra, and then to finish the process, I'll write the name of the second element, but again, just like before, I have to change the ending to IDE. And so we have carbon tetrafluoride for the name of CF4. So let's go ahead and move on to the next one. On the next compound, we have SiO2. And so following the rules along from last time, we need to name the first element and determine how many atoms there are. And so silicon doesn't have a prefix to the right of it. That means there's only 1, but we're not going to write monosilicon. We're just going to write silicon. Now looking at the second element, there are going to be 2 atoms of oxygen, and so we need to use the di prefix. And so that would be silicon, and we would write di, and then we need to name the second element, and that's oxygen, but we need to drop off the ending and replace it with IDE. And so that's going to be silicon dioxide. Again, it can be really confusing to know that this is all of oxygen's name that we actually kept. You'll get pretty comfortable with this after a few more tries, but another way to know that oxide is the right answer is if you tried to keep more of the element name, like oxy, and add on IDE, that would be oxyide, and it sounds kind of strange. We could try OXYG and add the IDE, and it would be oxygenide, and that sounds weird too. And the more you work with this, the more you realize that you've heard terms like oxide in everyday life. So let's move on to the next one. For the next one, we've got NO2. And so N on the periodic table is nitrogen, and there's only 1 atom of it, but we never write mono for the first element. For the second element, we've got 2 again for oxygen, and so that's just going to be nitrogen dioxide. And that one's all done. So let's go ahead and move on. For this compound, we've got carbon, and there's only 1 atom of it, but we don't write monocarbon. And just like the last example, we have 2 oxygen atoms, and so that's going to be dioxide. And this one's all done. So let's move on again. Now for this one, we've got carbon and oxygen, and we only have 1 atom of each. And so that would start as carbon. We wouldn't write mono for the first element, but because there's only 1 atom of oxygen right here, then we have to name that element with a prefix of mono, and we're going to go on and add on oxide for the oxygen, and we change the ending to IDE. Now technically there is a missing O in here because mono and oxide have an O on the end and the beginning of both of those words. But when you have that, you just drop off one of the O's because it sounds kind of strange to say monooxide. And that's a pretty easy rule to learn because you've probably heard of carbon monoxide before. Now going over to the back of the page, let's start again in the middle because that line divides the 2 types of problems that we need to learn how to do. Now on the back, we have names of elements, and we're going to write chemical formulas for them. But the first step to any problem remains the same. We have to decide, is the substance ionic or is it covalent? Well, looking at this dinitrogen pentoxide, it's a little tough to figure out which elements we're talking about, but this would definitely be nitrogen for that part of the name. And then oxide down here, that's definitely oxygen. And so we have two nonmetals, and so that makes these at the top of the page covalent because they're both nonmetals. So if you've got that on your page, let's go back to the top and start figuring out how to write formulas. So at the top of the page, we have carbon tetrachloride. And so for the first step, we need to write the symbol for the first element. And so carbon, that's just plain C. And we use a subscript for step 2 to show the number of atoms. And so carbon doesn't have a prefix on it, and so that means there's only one atom of carbon. But we never write a subscript of 1, and so we're going to move on right now to step number 3. For that, we need to write the symbol for the second element. And the second element is going to be chlorine. And so for step 4, we need to use a subscript to show the number of atoms. Well, tetra right here is the prefix. And if you go back and look at that table of prefixes, tetra means that there are 4 atoms of chlorine. And so this one's all done right now. So let's go ahead and move on to the next one. For phosphorus trichloride, we can repeat the process. On the periodic table, phosphorus has a symbol of capital P, and chlorine has a symbol of Cl. Phosphorus doesn't have a prefix, and so we're not going to write a subscript of 1, but the tri prefix on chlorine means that there are 3 atoms of chlorine in that molecule. So this one is done. Let's go ahead and move on. For the next one, we've got carbon. Carbon doesn't have a prefix, and so we're not going to put a 1 for a subscript for that. For the last part, we have sulfide, but that means on the periodic table, we'd be looking for sulfur, and that's capital S. The prefix of di, that means 2, and so the formula for this would be CS2. And so we're all done right here. Let's go ahead and move on. And so for the last one in this section, we've got dinitrogen pentoxide. And so nitrogen right here, that's periodic table symbol capital N. And we have a prefix of di, and so that means we have 2 atoms of nitrogen. For the last part, we have oxide, and that's just plain oxygen, and we have a prefix of pent. And the pent prefix back on the table means 5. It's kind of like a pentagon has 5 sides. And so now we have the formula of dinitrogen pentoxide is N2O5. Now we're back to that dividing line in the middle of the page. And if we look at the first example in this section, magnesium chloride, we need to go back to that first step of any problem and decide, is this ionic or covalent? Well, magnesium is on the left-hand side of the periodic table, and chlorine is way over on the right. And so that's a metal and a nonmetal. And so we can add that to our sheet, that everything in this section is ionic because they're a metal plus a nonmetal. Now, if everything up to this point has been pretty easy about writing these names and formulas, this section is definitely the most difficult to learn and remember. And so we're going to add a little bit more notes into this worksheet than we have already. The first thing we need to get is the idea of oxidation numbers. Oxidation numbers are the charge that an atom will get when it forms an ion by gaining or losing electrons. Like, for example, if we went back to a previous unit and we had sodium and it had 1 valence electron, well, if it gives that electron away to somebody else, that would make it end up with a positive 1 charge because it lost a negatively charged electron. Now, it can take a little bit of math to figure out the oxidation number of an element, but there's a really easy way to remember the oxidation number of any element in groups 1, 2, and 13 through 18. And it goes like this. The oxidation number of anything in group 1 is positive 1, and anything in group 2 is positive 2. Anything in group 3 has an oxidation number of plus 3. Anything in group 15 has an oxidation number of minus 3. Group 16 has a charge of minus 2. Group 17 elements form a negative 1 charge, and group 18 elements, they don't bond with anything, and so they have an oxidation number of 0. Now for group 14, you'll never be asked about the oxidation number of any element in group 14, and so we're going to write skip right here. Just to put one more example in here, chlorine, that's in group 17. And if you remember, that means it has 7 valence electrons on its own. And so if it were to bond with another element by taking an electron from it, that would make chlorine have a -1 charge. And so that's where this -1 in the table comes from, and that's really the same process for any element in any of the groups that we've written down. Now you can just memorize this table on its own, but there's a little saying that you can memorize, and it kind of has a rhythm to it that'll help you when you get a blank periodic table like this one, and you need to write down the oxidation numbers just to be able to do these problems. It goes like this: +1, +2, +3, skip, -3, -2, -1, zip. Now, zip stands for 0, and I put it in there because it rhymes with skip, but the overall rhythm of that saying can definitely help you memorize and then put the oxidation numbers onto the top of the periodic table whenever you need it. So let's go ahead and move on to the next set of problems. Now, for this one, we've got magnesium chloride. And I did mention already that this is the toughest set of problems. The other 3 are pretty easy, so definitely pay attention for this part, even if you thought the other parts were really easy. For step 1, we're going to find the oxidation number of both elements. And so magnesium, if we went back to the periodic table, that's in group 2. And so that would be a +2 charge. And then chlorine is all the way over in group 17. And so that would be a -1 oxidation number. Now for step 2, we need to write the symbol of the positive ion. And so magnesium, its symbol is Mg. And then for step 3, we're going to write the oxidation number up above the symbol itself. And then we're going to repeat the process for step 4 and 5, because we'll write the symbol for chlorine, the negative ion, and we'll put the -1 up above it. Now for step 6, we're going to use the crisscross method. So watch what I do with these numbers up at the top. I'm going to bring them down and put them as subscripts, just like this. They're going to cross places. And so I'm going to write a 1 right here for magnesium, and I'm going to write a 2 right here for chlorine. Now notice that I did not bring down the charges. I left the positive and negative behind, and I only brought the numbers down themselves. Now for step 7, we can reduce to the smallest whole number ratio if needed. Right now we've got a 1:2 ratio, and so we can finish this up and say that the final answer is MgCl2. And so that would be the final answer. We couldn't leave it with all the scratch work on top of it. It's a little bit hard to read, and so we just need to rewrite these kinds of problems. So moving on to the next problem, we've got sodium sulfide. And so we need to find the oxidation number of both elements. Sodium is in group 1, so it's +1, and sulfur is in group 16, so it's a -2. So we're going to write the symbol for the positive ion, sodium. That symbol is Na, and we're going to put the +1 up above it. And then we're going to write the symbol for the negative element, and that's S for sulfur, and we'll put its charge up here. Now for the crisscross method, I'm just going to bring those charges down, but I'm going to leave off the positive and negative and write a 1 and a 2 just like that. And so I can reduce that down to the whole number ratio, but really it already was a 2:1 ratio. And so that'd be Na2S, and that's the final answer. Now moving on to the next one, we've got calcium oxide. And so calcium, that's in group 2, so that's a +2. And we've got oxygen, and that's in group 16. And so that's -2. And so let's write the symbol of the first element with its charge, and we'll write the symbol of the negative with a -2. I'm going to use the crisscross method and bring those down. And so I'll put a 2 for calcium, and I'll put a 2 for oxygen. Now this step 7 on this one is actually something we're going to have to do, because we have a 2:2 ratio. That really is a simpler ratio of 1:1. And so we can drop that back to a formula of just CaO. Because again, there's really a little 1 right here as subscripts, but we never write those just for simplicity. So let's move on to the last problem on the page. We've got aluminum chloride. Now aluminum, that's in group 13, so it's got a +3 oxidation number, and chlorine is in group 17 with a -1. And so I can write the symbol of the positive with a +3, and I can write chlorine with a -1. And so I'm going to use the crisscross method and put the 3 and bring the 1 right there. And it looks like that's a 1:3 ratio, and so I can leave it as AlCl3 for the final answer. Now for right now, we're all done with the ones we need to do for now. So thanks for watching.